Right, so yeah, in this class we are going to see about counters, right? So in our last class, so we have seen about the flip-flops, about JK flip-flop and how the JK flip-flop works, right? We have seen about triggering techniques, the edge triggering and level triggering, and we have seen about both positive edge triggering and negative edge triggering flip-flops, right? So in this class, we are going to see about the counters, right? How we can use the flip-flops to do binary counting, right? So before going into that, I'll draw the truth table of JK flip-flop, right? What we have seen in our last class, right? So we have JK, QN and QN plus 1, right? JK, QN and QN plus 1, right? So these three will be our inputs, right? These three will be our inputs, right? So 0, 0, 0 and 1, right? So this could be 0, 0, right? 0, 1, 0, 1, right? 0 and 1, clear. 1, 0, 1, 0 and yeah, 0, 1 and 1, 1, 1, 1, yeah, 0 and 1, right? As we seen earlier, this is no change, right? Qn plus 1 will not change, or we can call it as no change, right? So this will be 0 and this will be 1, and this region actually for a edge triggering flip-flop, right? For a positive edge or negative edge triggering flip-flop, this will be toggling, right? For a level triggering flip-flop, this will be free running, right? We have seen about free running and other things in our last class, right? So for an edge triggering flip-flop, this is actually toggling, right? So if 0, we will be using it as 1 and 1 becomes 0, right? So when JK, in a JK flip-flop, when both J and K becomes 1, we can call it as toggle, right? Toggle means 0 becomes 1 and 1 becomes 0, right? So for example, if I draw a JK flip-flop, right? A JK flip-flop, I have a clock, right? So for a edge triggering flip-flop, I need to have a triangle, and if I have a circle in front of it, then that means it is a negative edge triggering flip-flop, right? So we have J, K, Q and Q bar, right? Q and Q bar, right? So once J and K are connected to a high voltage or 1, right? So 5 voltage, for example, or we can say it as a digital 1 or high, right? And then just assume that we are giving a clock pulse, something like this, right? As I said, it's a negative edge triggering flip-flop, right? Negative edge triggering flip-flop. So your Q will change whenever you are encountering a negative edge in the circuit, right? For example, I'll draw the clock, right? So clock, right? So something like this. I'll draw it a bit bigger, right? Okay, maybe. So negative edges are this one, right? This is your first negative edge. This is our second negative edge, right? So your Q is, or Q will change whenever you are encountering a negative edge. For example, right now, yeah, J and K are connected to 1, right? So this is going to be working, right? J and K are connected to 1. So your Qn has to be toggled, right? So for the very first pulse, let's assume that Q is 0, right? Q is 0. Whenever the first negative pulse is detected, that is going to be toggled. So Q becomes Qn plus 1, 1. And that 1 will be kept constant until the next negative pulse is encountered. right? Whenever the next negative pulse is encountered, right, again. So your Q is 1, right? Q n is 1, J equals 1, K equals 1. So that need to toggle. So it will simply go down to 0, right? So for the first pulse, it is 0. For the second pulse, clock pulse, that is 1. Again, for the third pulse, it becomes 0, right? So this is a working principle of a simple JK flip-flop, right? Okay, now let's see how we can use these JK flip-flop under 1-1 biasing, right? Under J equals 1 and K equals 1, and how we can use it as a counter, right? So let's consider a circuit, right? Okay, this is the basic, right? So now we'll consider a series of JK flip-flops, right? So right, we have A, right, B, C, right, flip-flop A, B, C, right, all are JK flip-flops, and what I have done is, right, J, A, K, A, right, so this is your J, A, K, sorry, J, B, K, B, J, C, K, C. Can you see the letters? Can you see my handwriting? Any problems in or you
No,
can
sir.
send a message on chat, right? You can see it clearly, right? Any problems, or do I need to draw it a bit bigger?
No, sir, it's clear.
Okay, right. So these are what I'm doing is I'm going to connect all these J and K into a high voltage, which means I am making that these JK flip-flops are working under toggling condition, right? Or 1 or 5 voltage or high, right? You can use any notation, right? 1, 5 voltage or high, right? And then first I will connect it to a negative edge triggering flip-flop, right? This is my clock, right? So this is my QA, QA bar, right? So this will be QB, this will be my QC, right? What I am doing is I am going to give this as the clock, right? I am giving my QA as the clock to the flip-flop B, and then I am going to connect QB to the clock of the flip-flop QC. Right, now we have QC, right? So if we get the output from here, right, so this will be my QA, this will be my QB, and this is my QC, right? Let's see how this circuit works, right? Or how this circuit works whenever you are introducing clock pulse to it, right? So now consider this as your clock sequence, right? Consider this as your clock, right? This is your clock, right? This is your clock, right? So this is what I am giving here, right? This is what I am giving to the clock, right? So let's see how QA changes, right? How QA changes, right? Let this be QA. As I said, all these are negative edge triggering flip-flops, right? So before going to solve the problems, let me mark all the negative edges in the clock pulse, right? This is the negative edge, this is the negative edge, negative edge, negative edge, negative edge, negative edge, and this is my negative edge, right? Why we choose these negative edges is actually your counter will count once the clock pulse is completed, right? So this is your positive edge. So negative edge means the pulse is completed, right? That's why we are using, or we can use positive edge as well, right? It is not mandatory, but let's see how the circuit works, right? For the QA, assume that at initial stages all these flip-flops are at 0, right? So QA equals, QB equals, QC equals 0 when T equals 0, right? So let's see, this becomes 0, and whenever the first clock pulse is encountered, or whenever the first negative edge is detected, yeah, your output will be toggled. Am I right? Your output will be toggled, and that will be maintained until it is detecting the second negative edge, right? And then that will be toggled, right, again, right? So this will be changing something like that. Clear, right? Now what I am doing is I am giving QA as the clock to the flip-flop B, right? So it is going to derive by the clock signal derived from A, right? So I'll mark the negative edges in the output of QA, right? So I have 1, 2, 3, 4, right? Now let's see how we can mark our flip-flop QB, right? The output of QB, right? Let this be QB, right? So it is 0 initially, and until I am receiving the first negative edge, that will be maintained as 0, and whenever it is detecting that negative edge, the output will be toggled, because J equals K equals high or 1, right? So that again, whenever it is encountering the next, it will be toggled to 0. Right, so this will be the output of QB. Now, what I am doing is I am giving QB to the flip-flop QC, which means this is the clock pulse to the flip-flop C, right? But there also I am making JC, KC into 1, right? So what I can do is, let this be my QC, right? QC, and I'll mark the negative edges in the clock pulse, or QB, right, which is the clock signal for QC, right? I have only 1 and 2, right? 1, 2. So until I am receiving my first negative edge, that will be maintained at 0, and then whenever I am encountering the negative or edge, it will be triggered or toggled, and then that will be kept constant, right? So this will be my QC, right? Now, okay, this is the end of first pulse, am I right? This is the end of first clock pulse, right? This is the end of second clock pulse. This one is the end of third clock pulse, right? Fourth clock pulse, fifth pulse, sixth, seventh, and eighth. Clear, right? Now let's see, what is your QA is 0, QB is 0, QC is also 0, am I right? So I can say it as, right? Okay, we'll fill it first, right? Now for the next pulse, QA becomes 1, but QB is 0 and QC is 0. For the third pulse, QA becomes 0 again, but QB becomes 1, but QC remains 0. Right? For the fourth pulse, again QA becomes 1, QB is, right, still 1, and QC is again 0. For the next one, QA becomes 0, but QB is also 0, but QC becomes 1. Right here, 1, 0, 1, 0, 1, 1, and this one, 1, 1, 1. Again, 0, 0, 0. Clear, right? Now I'll write down the equation, right? So let's take it QC as your most significant bit, right? I'm just taking upside down, right? I'm taking QC as my most significant bit, right? So I'll write the variables something like this, right? QC, QB, QA, right? QC, QB, QA, right? This will be 0, 0, 0. Right here it is 0, 0, 1, 0, 0, 1. Again this one 0, 1, 0. This one 0, 1, 1. This is 1, 0, 0. This one 1, 0, 1. This one 1, 1, 0. This is 1, 1, 1. Again this becomes 0, 0, 0. Right? If I write down the decimal equivalents, right? If I write down the decimal equivalent, I would say it as 0, 1, 2, 3, 4, 5, 6, 7, and then 0 again, right? 0 again, right? So this circuit is called as an up counter, right? Up counter because it is starting in the ascending order, right? 0, 1, 2, 3, 4, 5, 6, and 0, right? So these circuits are called as the up counter, right? Now let's see how we can make a down counter, right? This is an up counter. Since we have 3 flip-flops, it is a 3-bit up counter, right? So when you have 4th flip-flop, it will become another flip-flop QD, right? That will be having, yeah, this will be your first negative pulse, and then you will have another negative pulse in the 16th clock pulse, right? You can draw it as per the diagram, and then again you will get 0 to 15, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then 16 becomes 0, 0, 0 again, right? So these are called as your up counters, right? Binary up counters. Now let's see how we can make a down counter. Right? Yeah, down counter is nothing but here I have connected QA to the clock. Am I right? I have connected QA to the clock. Right now, what we can do is I can simply connect QA bar to the clock. Right? The down counter means I can simply connect QA bar to the clock. Okay, I'll draw the circuit now. Right? But again, JK should be connected to high because the counter operation will requires the toggling of your flip-flops. Right? So, okay, draw the circuit diagram. Right, so JA, KA should be connected to Z, sorry, 1. Right, this is connected to a 1 O high, right, 1 O high, right? So this is JA, KA, JB, KB, JC, KC, QA, QB, QC. Right now, okay, this is my clock pulse. I am using negative edge triggering flip flop, right? This is edge triggering and negative, right? So here this is my clock, right? Again, what I am doing is QA bar, QB bar, QC bar, right? I'll connect. Right, so now I have QA, QB and QC. Right, now let's see how the counter works. right? How this counter works, right? Let this be my clock pulse, right? I have my clock pulse, and then I have QA, right? I have QA and QA bar. Remember, I have to draw both, right? So first, I will mark the negative edges, right? Negative edge 1, 2, 3, 4, 5, 6, 7, and this is my 8th negative edge. Oh, maybe I have my 9th negative edge as well, right? All these are my negative edges, right? So I can write QA as, right? I can write QA as, okay, first, and then whenever it is encountering the first clock pulse, the output is toggling, again toggling, right? Becomes 1, 0, 1, 0, 1, 0. Clear, right? But what I have done is I have given QA bar as the clock, right? So QA bar means I have to draw QA bar as well, right? So let me draw QA bar, right? QA bar, right? So if it is 0, and simply QA bar is 1, right? Right, this is my QA bar, and then I have negative edges here, 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 and maybe here, right? I have negative edges here, 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 right? So based on that, I am going to determine my QB, right? I am going to determine my QB. Right, so QB is okay. Whenever I am encountering my first clock pulse, it has to change, right? So let that be 0, and then whenever the first pulse is encountered, that becomes high, and then becomes low, becomes high, then becomes low, then becomes high. Clear, right? But again, I'm giving QB bar as the clock, right? So we need to draw QB bar as well. So when it is 1, I can write it as, yeah, that becomes, sorry, if it is 0, that becomes 1, right? 0, 1, 0, 1, 0. Clear, right? Now I can mark my negative edges, edge 1, edge 2, and edge 3, right? I can mark my negative edges, and I am giving this signal, right, QB bar, to the flip-flop C, right? But we can determine QC, right? So let's take QC here, right? So until I am receiving my first pulse, it is 0. Whenever I am encountering my first pulse, that becomes high, and then until I am receiving my next pulse, that maintains at high, and then it becomes 0, then it becomes 1. Clear, right? So these are my, so what I need is actually, of course, I have drawn QA bar and QB bar to determine the next level pulses, but for my clock pulse calculation, I need only QA, QB, and QC. Right now, I'll mark QA, right? So this is QA 0, 1, 0, 1, 0, 1, 0, 1, 0, and then 1. Am I right? All right, I can simply mark 0, 1, 0, 1, 0, 1, and 0, 1. Right? Same time, I can mark QB as 0, right? 1 and 1, right? So this becomes 0, 0, 1, 1, 0, 0, 1. Clear, right? I don't want to worry about QB bar because that is necessary only for determining the next level. And QC, I can make it as 0, 1, 1, 1, 1, 0, 0, 0, 0, 1. Clear, right? Now, let me write it from bottom to top, right? QC, QB, and QA. 0, 0, 0. Right, so at these spells it becomes 0, 0, 0, and then for the next one it is 1, 1, 1. For the next one 1, 1, 0. Next one 1, 0, 1. For the next one 1, 0, 0. This is 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 0, 0, and then for the next one it becomes 1, 1, 1. Right? If we write down the decimal equivalents, it becomes 0, 7, 6, 5, 4, 3, 2, 1, 0, 7. Right? What is happening is it is simply counting downwards. Clear? So this circuit is actually counting downwards. Right? So we can call it as a down counter. Right, we can simply call it as a down counter. Right, so this is an up counter, so which means in simple words, if you give QA bar, QA to the clock of the next flip-flop, that becomes up counter. If you give QA bar to the next level of flip-flop, right, to the clock of the next level of flip-flop, that becomes down counter. Clear? Right, so that's the basic of up and down counters. Now let's see how we can make both up and down counter in a single circuit, right, which is called as an up and down counter. Right, up and down counter. Right, so in simple words, what we have to do is, right, if you want to make an up counter, right, QA need to be given to the clock. Right, QA need to be given to the clock, and if you want to make a down counter, QA bar need to be given to the clock. Clear? Right, so we need a circuit in the middle. We need a circuit in the middle which has to switch QA and QA bar based on the operation you need. Right, so we have seen about multiplexers, right, 2-bit multiplexers, which is a simple circuit. Right, 2-bit multiplexer, as I said, you will have a select signals. Right, 2-bit multiplexer, okay, I can draw it. Right, in circuit diagrams I could say it as you will have 2 lines and 1 select signals. Right, so this will be maybe data 0 and data 1, and this will be your select signal S0. Right, if S0 is 0, this will be connected to Y, and if F0 is 1, then D1 is connected to Y. Right, so we are going to use a single bit or a 1-bit or 2x1 multiplexer in the middle. Right, the circuit of a 2x1 multiplexer is actually, this is my S0. Right, we have seen this in our last class. Right, in our previous, sorry, this is a not a diode, sorry. Right, so this becomes S equals 1 and this S equals 0. I have 2 AND gates. Right, this is my, right, D0 and D1. Right, so this is 0 and this is connected to 1 and D1 is connected to here, and both has to be given to an OR gate. Right, so this is your Y. Right, which means if S is 1, you will have D0 as your Y. Right, if S is 1, sorry, if S is 0, then you will have D0 as your Y, and if S is 1, you will have D1 as your Y. Clear? Right, so we are going to use the same thing in here. Right, so if it is an up and down counter, you need another input which is called a line, right, which is up down bar. Right, up down bar, which means if this input is high, then your counter has to work as a up counter, and if it is low, then your counter has to work as a down counter. Right, so we can use this as my select signals here. Right, so I can give this as a select signals, and in this one I can use QA and QA bar as my data lines, right? As my data lines. Or if I draw the circuit diagrams, right? If I draw the circuit diagrams, I can put two AND gates, right? So which is right QA directly connected, QA bar which is directly connected from the flip-flop, right? So what I can do is, since it is up, it can be directly connected, and down means I have to invert it. Sorry, right? It is not connected. Clear, right? Which means if this is high, then QA will be the Y, right? Up means QA will be your Y, right? QA will be your Y, and if it is 0 or down means QA bar will be your Y. Right now, let us draw the circuit diagram, please. Right? Let us draw the circuit diagram. First, we'll have JK flip-flops. Right, both J, K, all J's and K's are connected to one. Right, high, right? But so JA, KA, QA, right? So this is QA bar, right? JB, KB, JC, KC. Right now, yeah, this is my clock and negative edge triggering clock. Right now, in the middle, I need a circuit. Right in the middle, I need that multiplexer circuit. Right, so we'll have a line here. Okay, make it as right up, down, bar, right? Which means if it is 1, it has to work as an up counter, and if it is 0, then it has to work as a down counter, right? So we'll make a NOT gate, and then we'll make that line as well, right? So this is 1 and this is down. So I can simply say this is up and this is down, right? So this is QA bar, right? So up, I can put up from here, and down from here, and then I can give both of them to an OR gate, and that I can give it to the clock, to the next level. Clear? Right, again I can do the same thing there, right? So QB and QB bar, right? So I can draw a negative edge triggering flip-flop, right? So this will be my QB, and that has to be connected to high, and then this is my low, and that has to be connected to QB bar, and this is my QC and QC bar, right? So this is actually a kind of an up and down counter in a single circuit, right? Right, let's see how this up and down counter works. Right, how this up and down counter works. Okay, for example, I will mark the negative edges here. Right, also I need the up and down line as well, right? So I can make first, it is high, right? High means it is going to do the down counting, right? So it is high. Oh no, you can't see that, right? It is high for the first 7 pulses. So it is okay, maybe to the next pulse, and then it becomes down, then it becomes 1, right? So this is up down bar, right? The brown line is actually up or down bar. Means if it is high, your counter has to work as an up counter. If it is low, then your counter has to work as a down counter. Right now, okay, up it's 1, and then we'll draw the output of your flip flop A. Right, our flip flop A. Right, so okay, clock is okay, and it does not depends on whether it is up or down. Right, so simply it will be, yeah, I can draw, yeah, 1 line down, right? So it will be 0, and then whenever it is occurring, yeah, high, right? This keep on continuing. Right, now I'll mark the negative pulses here. But again, remember, I need my QB bar as well, because whenever the up and down is low, then that will be triggered, yeah, from the Q. So if it is QA, I need QA bar as well, right? So I'll draw my QA bar, right? So if it is low, that is high, low, high, low, high, right? So I will have my right. Again, these are my negative edges of my QA bar, right? Okay, now let's see how we can do the pulses of QB, right? QB, okay. Whenever your up and down is high, right? Up and down is high, of course, the clock pulse will be simply QA, right? Simply QA, and then that will be triggered, right? If it is QB, that will be triggered by QA, right? So you will have 0, and then it will be triggered by high, and then that will be toggled, then high, and then right. Now look at here, in the middle, right? In the middle of that pulse, it becomes down, right? Down means for the next pulse, the your circuit is going to be triggered by QA bar, right? So once it becomes low, right, this is no more your triggering pulse. Your QA bar will be the triggering pulse, right? So this will be keep on continuing, and at this position it becomes low, means it has to be triggered by QA bar. Now you cannot, you have to consider the bottom one, right? So that becomes, and then it will be toggled here, right? Again it is toggled there, right? And then right at this point again up, the up, right, up down bar becomes high, means once again, right, your circuit or QB is going to be triggered by QA, right? For the next pulse it is no more triggering this one, and it will be triggered by the other, this one, right? Not this one, right? So that will be keep constant, and then that will be triggered, right? This is how the circuit works. Now we need QB bar as well. Okay, we need QB bar as well, because to draw the pulse signal, right? So let's take QB bar, right? If it is 1 0, that becomes 1 0. Clear, right? So I'll mark the negative edges of negative edges of both QA bar and QB bar. Okay, that's it. Right now, let's see how QC changes. Right now, let's see how QC changes. Right, so now, okay, at this one, I am transferring this one, yeah, up is high, right? Hence, it will be clocked or triggered by the signal QB, right? So I can draw it, that is 0 until the first negative pulse. Yes, here I'm interfering that I'm encountering the first negative pulse, and then that becomes continuing. Yes, at this position, it becomes down, which means, yeah, your QC is going to be triggered by the QB bar, not QB anymore, right? So that will be kept constant until I am encountering the first negative pulse of QB bar, and then I am coming out. Yes, at this position, it is up again, right? Up again. But I don't have any clock pulse, and that will be keep on continuing, right? That will be keep on continuing, right? Now, that's all my diagrams, right? That's all my diagrams, and I can write my numbers, right? So this is my QA, right? So QA is 0 1 0 1 0 1 0 1 0 1 0 1 0. QB 0 0 1 1 0 0 1 0 0 1 1 1 0. Clear. For QC 0 0 0 0 1 1 1 1 1 0 0 0 0. Clear. Right now, let me write down it. Right. So 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1. This one 1 1 0 1 0 1 1 0 0 0 1 1 0 1 0 0 1 1, right? Again, this becomes, yeah, so this is 0 0 0. Oh, sorry, I forgot it, right? If it is up, right? So I have to change up, and then that will be, yeah, clocked. This one, right? Sorry, mistakenly I put it. And this becomes 1, right? So that is 1 0 0, right? Because, yeah, since it is high, then my triggering is actually QB, not QB bar. Now, let me write down the equivalent decimal numbers, right? So 0, 1, 2, 3, 4, 5, 6, right? So 101 is again 5, 1004, 0113, 010, 2, 0113, 1004. See here, until this point, right? If it is up 0, 1, 2, 3, 4, 5, 6, right? It is going up. And then from this point to this point, see, 6, 5, 4, 3, 2, it is coming down again. And then whenever it is coming up, again it is 2, 3, 4. Right? So this is how an up down counter works. Right? So we are simply using a select signal which is up down bar, right? Which means if the up down bar is high, then your counter has to work as an up counter. If this is low, then your counter has to work as a down counter. Right? It's nothing but choosing your QA and QA bar to the clocking or the next level, right? So any questions on this one? Any doubts? Hello? Yeah, you can unmute and talk. Any questions or any doubts? No doubts.